Hey, welcome Algebra 2 students. This is Mrs. Cook and we are working through Chapter 5, Assignment Number 4, which is Applications of Quadratic Equations. On number 1, I'm going to give you a moment to pause the video, read the problem through, and then join back. Okay, come on back to me. Here we go. I am going to ask that you kind of start thinking about this problem in terms of a table. So I've set up some words here for you. I'm thinking about price, which right now is 40 cents a copy. And then 50,000 of these are going to be in print. So right now, if you wanted to multiply 0.4 times 50,000, you could go ahead and get your income. Now, as we were doing this in class, we kind of did a few of these where we multiplied, like in this case, we 0.5 if we raise 10 cents increase in price, that we're going to lose 5,000 customers. So we'd have 45,000 sold. And we did 0.5 times 45,000 and wrote that here and kind of got an idea of what was going on. But the key is to write expressions now for our price and our circulation. So can you go ahead, pause the video, and try to write those expressions? Okay, back to me. I'm going to ask you to pause the video a lot today and try to think these through on your own, and then coming back to me. You can see that this is 40 cents plus 10 cents per increase. Now this is going to be really important that on these types of problems, you always let X be the number of increases. All right, so where I had 40 cents plus 10 cents per increase, the circulation, however, was originally 50,000, and now we're going to lose 5,000 sales per increase. And how did we get income? Again, in class, we multiplied here times here to get this, and if you wanted to, you could take some time to do that, but this is the end goal. Can we now write the function that represents what's happening here? And indeed we can, because we're just going to multiply this expression times this expression. And when I do that, my 0.40x, or I'm sorry, 0.40 plus 0.10x times 50,000 minus 5,000x, I will get this function that I can clean up a little bit by foiling. So again, pause the video, go ahead, clean up your expression or clean up your equation. Let's see what you come up with. My equation, when I clean this up a bit, is f of x equals negative 500 x squared plus 3,000x plus 20,000. Now, what are we trying to do? Well, we're trying to maximize income. And if you think about our little graph right now, we have x, which is the increases, and then y is the income. And we want to know in this parabola that's going on, this quadratic, as we increase price, we make more money, make more money, make more money, but then eventually we increase the price so much that we lose so many customers that we're going to lose money. We want to know, where is this perfect point right there? Where is that maximum? And we've been finding that in class by finding first the axis of symmetry. The axis of symmetry is the equation x equals negative b over 2a, or I should really say the opposite of b over 2a. So I'm going to take a moment and calculate that. You can go ahead, calculate that with me. That's negative 3,000 over 2 times negative 500. Okay, so that's a negative 3,000 over a 1,000, and I get 3. Now remember what we're solving for there. That's 3 increases. So this would be 3 increases is what we're advising for the circulation. 3 increases. If I take a look here at the price, each increase was 10 cents. So start at 40 cents, but raise 10 cents 3 times. That would be our advice. Therefore, our answer, what price per copy, should be 70 cents. Now, if I asked you to, and I don't in this case, but if I asked you to tell me what the income was, well, think about that. We know that the x here is 3, and we would want to know y, which is right up here. So I could take 3 and substitute it back in to my function to calculate the y. That is maximizing income. The next problem deals with maximizing area. So let's take a look at the next problem. You can see I have this lovely diagram of what's going on. Go ahead and pause it and read it for a minute and come on back to me. Okay, so what is this picture? Oh my gosh, how embarrassing. I've admitted to you before I'm a terrible artist. But anyways, this is the house, and then we have this kennel on the side for the dogs. And you can see that one side of the kennel is going to be the house. So that means when I'm setting up my perimeter, I really have 2 widths and 1 length. Or you can call these lengths in that width, that doesn't matter, or base and height, or A and B, whatever you want to refer to those as. But 120 feet of fencing is going to be needed for 2 W's and 1 L. Now, what we were doing is solving for one of these variables, and I'll tell you why we do that. That's because we're trying to maximize area. So I'm thinking about my area of this rectangular region being length times width, or width times length. I can go ahead and use some substitution. You see I have 2 equations, and when I have 2 variables, I can solve the system using substitution. So I can substitute that guy right there. That tells me that my area is width times 120 minus 2 times my width. I'm going to distribute to get area is 120W minus 2W squared. And all of a sudden I say, oh, W squared, that's a quadratic. So if you wanted to write it in the other order, you certainly could. My AX squared plus BX plus C, although C in this case is 0. And now, again, think about what we're trying to do. I would encourage you to think about what our function represents. Right now, I have this as width. Again, I could have called it length. That doesn't matter. That's my W. And then my Y value is area. So we're going to increase our width. And as we increase our width, we're going to increase the area, keep increasing the area. But then eventually, we're going to make it so wide that it's going to become so short that the area will go down. And we're looking for this point right there. How do you find that? Yes, yes, yes. We want to find the axis of symmetry. So I'm going to do x equals negative b, or I should say the opposite of b, over 2a. And so that is a negative 120 over 2 times negative 2. That's a negative 120 over a negative 4. Negative divided by negative is a positive, so I'm going to get 30. Now in this case, they do want to know the length and width, so some options for you here. If I took this x and I substituted it back in here, if I took this x, which was my width, x is the width, and I substituted it back in here, that would tell me the area. So my area is 1,800 square feet. Now, can I get the other dimension? Certainly, I could take 1,800 and divide by 30 to get 60. That's one option. If you don't like that, you could have said, well, I know that length is 120 minus 2 times my width. So you could have substituted your width right back in there to get 120 minus 60, which is again 60. So either way, whatever you prefer to do, your dimensions are going to be 30 by 60 square feet. Oh, I'm sorry, 30 by 60 feet. Oh my goodness, it's getting too late. 30 by 60 feet, which gives me an area of 1,800 square feet. If they ask me for the area, I would state that. Okay, so at this point, you should have the tools to do number 3. I'm going to not work it through in this video. I will tell you the answer, although you certainly could find the answer on my website. The answer is 3.5 increases. I guess that's not really the answer though. Hold on. I get 3.5 increases to get an answer of $11.50. And if you can't get that to work, go ahead, come on in for some help. Okay, moving along. You also should have the tools to do number 4. Number 4, I'm going to get 10 increases, which again is not my answer. My answer then would be $350. Again, if you can't get that, let's talk about it in class or come on in after for some help. Or you could actually look at my answers on my website to see if maybe you just made a sign error or something like that. And then number 5, it is going to be 2.5 increases if you've done it correctly. 2.5 increases, so that would be $3.50 as an answer. Okay, so hopefully you have the tools to do those. The last learning target on our applications day was going to maximize height. So let's do this last one, and this is why I have the Inspire pulled up here, because I want to actually take a look at what this is doing in a moment. But right now, look, they gave me the initial velocity, that's my v sub 0 of 64. So we plug our initial velocity right in there to get this equation. They want to know how high is the ball after 1.5 seconds. Well, what they're asking me for is h of 1.5. They're asking me to plug in 1.5 into my t value. So I have negative 16 times 1.5 squared plus 64 times 1.5. Now notice on the Inspire that I have a graphing page in here because I am going to graph, let's see, negative 16 t squared. Now don't use a t, you need to use the variable button, which is the x there, squared, where am I at, squared, and then plus 64x. Okay, so I am going to graph that to get that graph. However, if I'm going to do a calculation like this and I'm in a graphing page, remember to just use the scratch pad right here. It's a nice feature of the Inspire where I can just use the scratch pad and then I can go ahead and plug this in to calculate. I have the answers here. I know that the answer is going to be 60, so I won't take your time to do that, but you could pause it and type that in to make sure that you get 60 feet. Okay, once you're in the scratch pad, you can just hit escape and then it's going to get you back here. Now notice I don't really see a parabola going on. I mean, I know it looks like I'm here at 0, 0 and it's going to shoot upwards, but I'm not sure how high up. So that's why I'm not going to go to the calculator just yet. I can calculate the maximum height reached by hand. And that's because we're talking about this object being launched. It's launched from the ground, and I can tell that because there is no h sub 0 initial height here in the formula. So I know it's launched at 0, 0. When my time is 0, my height is 0. And then it's going to shoot upwards over time and come on back down. And we're looking for that point right there. Well, we can find the axis of symmetry. So that's x equals negative b over 2a, or the opposite of b over 2a. So let me calculate that. That would be the opposite of 64 over 2 times negative 16. That's a negative 32. So this actually works out nicely. I get a positive 2. Now be careful. 2 is not your answer. Notice 2 is your x. It's your time. So it's 2 seconds to reach the maximum height. But now let's figure out what that maximum height is. I'm going to plug it in to do negative 16 times 2 squared plus 64 times 2. And this is where I'm going to get 64 feet high. So my answer is at 2 seconds, my maximum height is 64 feet. My answer is 64 feet. Now why does that help me on my graph? Well, you can see here I'm only looking at a maximum height of 6.67. So if I double click right there, I can change my maximum height. Let's change it to 70 because I got that 64 and now I see, oh, much better graph. So you can manually manipulate your window to see what you're looking for. Now it says how long to return to the ground. So there's a couple ways to do this one. I'm going to start with hopefully what you're using your intuition on. And that is the fact that this was launched from the ground. So this is launched from time being 0 and height being 0. And it shoots upwards and it took 2 seconds, right? It took 2 seconds to get there. That's my axis of symmetry. Which means it's going to take another 2 seconds to come back down and hit the ground. So my answer here, I know my answer is going to be 4 seconds. So that's using your intuition. However, I get a little bit nervous about that method because not every problem that we've done is launched from the ground. And you can see that if an object is not launched from the ground and shoots up and comes back down, that my axis of symmetry cannot just be doubled, because what about this piece right here? Then I'm off a little bit. So you can't always just double your axis of symmetry. And that's why I need you to know how to find this point on the calculator. Remember, we've been calling this a zero, we've been calling it an x-intercept, a solution to the quadratic, and a root. The calculator calls it a zero. So I'm going to do this two ways on the Inspire. The first way to do it is to just menu, trace, and graph trace. And now as I'm tracing to the right, it's going to lock on to what it considers some key features. So right there you can see it says, oh, maximum. The maximum occurred at 264. I couldn't read that, and I already knew that. There it is, 264. And then as I'm coming back downwards, it's going to lock on to another key feature right there. It's giving me a 0. Now I can't really see what it is. It's in my way. Oh, there it is. It came back as 40, or I could double click on it, and it would actually give me the point there. And then I could go ahead and grab that. If I escaped out, I could grab it. Having trouble with my tablet here. But then I can see it much clearer. So that is definitely 4 seconds. So that's one way to do it. That's just the trace graph trace. I like that feature a lot. It gives you a lot of key things. Another way to do it is more similar to what my 84 students, the 84 users are doing, which is to actually analyze the graph and finding the 0. On the 84, you went to second trace, which is calculate, and then the 0. What you have to do is go a little bit to the left, lower side of the 0 you're looking for. A little bit to the left, and then drag a little bit to the right, and you'll see there it is. It popped up at 40. So that was another option for you. Thank you guys for joining me in Applications of Quadratics.